Welcome to the computer learning series, that is learning computer with seeing the natural sights of Indian village. And in this series, in this lecture, I would like to talk about the distributed computing system. So a distributed computing system is a configuration which consists of many independent computer systems interconnected by a communication network, and in which cooperating computer system exchange message, programs data, processing task, and other resources over the network. Such such an arrangement enables sharing of many hardware and software resources, as well as information among several users who may be far away from each other. Individual computers of a distributed computing systems are referred to as nodes. That is, distributed computing systems are more complex and difficult to build than traditional centralized system due to following reason. Their design must enable them to use and manage a very large number of distributed resources effectively. Their design must include a special security mechanism to protect distributed shared resources and services against intentional or accidental security violation. Their design must enable various nodes of the system to communicate with each other reliably. For this, they need a special software to handle loss of message during transmission across network and to prevent overloading of network. However, advantage of distributed computing system outweigh these disadvantages. Now we see the advantage of distributed computing systems. First, inherently distributed application. Several applications require a distributed computing systems for their realization. A few example of such applications are electronic mail facility, a computerized worldwide airline reservation system, and a computerized banking system in which bank's customer can deposit, withdraw money from his or her account from any branch of the bank. Resources sharing. Next point is resources sharing, or advantage is resources sharing. Information is not the only thing that users of a distributed computing system can share. They can also share software resources like software libraries and database, and hardware resources like hard disk, plotters, printers, etc. Next advantage is information sharing among distributed users. In a distributed computing system, a user can generate information and share it easily and efficiently with other users working at other nodes of the system. For example, two or more users who are geographically far apart but whose computers are part of the same distributed computing system can work on a project together. In this case, the user can work in cooperation. For example, by transferring files of the project, logging onto each other's remote computers to run programs, and exchanging messages by electronic mail to coordinate their work. And use of distributed computing systems by a group of users to work cooperatively is known as computer supported cooperative working, CSCW, computer supported cooperative working, or groupware. This is also known as groupware. That is, computer supported cooperative working is known as groupware. Next advances of this system is best price performance ratio. That is, distributed computing systems potentially have much better price performance ratio than a single large centralized system because they facilitate resource sharing among multiple computers. For example, all computers of a LAN-based distributed computing system can share a single unit of expensive peripheral devices such as color laser printers, plotters, and high-speed storage devices. If these computers are independent and a standalone system, each computer will require a separate unit of each of these peripherals, resulting in a higher cost. Next advantage is higher reliability. A reliable system prevents loss of information even in the event of component failure. Multiplicity of storage devices and computers in a distributed computing system allows maintenance of multiple copies of critical information within the system and execution of important computations redundantly to protect them against a catastrophic failure. With this approach, if one of the computer fails, the system can complete the computation successfully on another computer. Similarly, if one of the computer fails, the system can complete the computation successfully on another computer. Similarly, if one of the storage device fails, the system can still use some information from another storage device having copy of the information. Next point is shorter response time and higher throughput. That is, in a distributed computing system provides shorter response times and higher throughput than a single centralized system because it has multiple computers which can work together to process more job in less time. For example, if a programmer can partition a computation into a number of sub computations that can run concurrently, a distributed computing system can run all sub computations simultaneously with each one on a different computer. Parallel processing system use multiple computers interconnected with very fast communication network to solve single complex problem rapidly. Another method often used in distributed computing system for achieving better overall performance is to distribute load more evenly among multiple computers by moving job from currently overloaded ones to lightly loaded ones. And the next advantage of distributed system is extensibility and incremental growth. It is possible to extend power and functionality of a distributed computing system gradually by simply adding additional resources, both hardware and software, to the system as and when we needs arises. For example, an organization can easily add an additional processor to its distributed computing system to handle increased workload that might have resulted from its expansion. Incremental growth is a very attractive feature because for most existing and proposed applications it is practically impossible to predict future demands of the system. And the last one is better flexibility in meeting users' need. Users need usually different types of computers are more suitable for performing different types of computations. For example, computers with ordinary power are suitable for ordinary data processing jobs, whereas high performance computers are more suitable for complex mathematical operations. And in a centralized system, users have to perform all types of computations on the only available computer. However, a distributed computing system may have a pool of different types of computers, in which case a user can select the most appropriate one for processing a job depending on the nature of the job. So these are the advanced uh, advantages of distributed computing system. Now we see the next topic, internetworking tools. Internetworking tools. Internetworking tools. Interconnecting two or more networks to form a single network is called internetworking, and the resulting network is called an internetwork. That is, connecting many LAN is a internetwork, and it is known as WAN. Now, internetworks often contains heterogeneous network that differ in topology and protocol. For example, some LANs of an internetwork may have multiple access bus topology, while others may have ring topology. Some of them may be using Ethernet technology, while others may be using token ring technology. Some segments of the network may be using the Internet Protocol suite, while others may be using System Network Architecture Protocol suite. It allows these relatively unrelated networks to evolve into a single working network. That is, the goal of internetworking is to interconnect different physical networks and to hide their details, enabling the internetwork to function as a single coordinated unit. The internetworking tool used commonly to interconnect two or more networks to form a single networks are: the first one is bridge. A bridge operates at the bottom two layers of the OSI model, which is physical and data link. Therefore, network designers use bridge to connect network which use the same communication protocol above data link layer. but may or may not use the same protocols at physical and data link layers. For example, a bridge can connect two networks, one of which use fiber optic communication medium and the other use coaxial cable, or one of which uses Ethernet technology and the other uses token ring technology. However, both networks must use the same high level protocols like TCP, IP or XNS to communicate between them. Next tool is gateway. A gateway operates at the top three layers of OSI model, and that is session, presentation and application layer, and it is the most sophisticated internetworking tool. Network designers use a gateway to interconnect dissimilar networks that use different communication protocol. That is, gateway interconnect two networks, one of which uses the internet protocol suite and the other uses the system network architecture protocol suite. Since a gateway interconnects networks that use dissimilar protocols, protocol conversion is the major job performed by gateway. Additionally, gateway sometimes also performs routing functions. And the last one is the networking tool is router. A router operates at network layer of OSI model. Therefore, routers do not care what topology or access level protocols the interconnected network segment use. Since routers use the bottom three layers of the OSI model, network designer use router to interconnect those networks that use same high level protocols over network layer. Note that protocols of data link and physical layers are transparent to routers. Therefore, if two network segments use different protocols at these two layers, network designer must use a bridge to connect them. Unlike bridge, routers do not view an inter-network from in to in. That is, bridge know the ultimate destination of a data, but routers know only the next routers for a data moving on a network. However, routers are smarter than bridge because they not only copy a data from one network segment to another, but also choose the best route for data by using information in a routing table to make this decision. That is, managing traffic congestion is a big plus of routers. They employ a flow control mechanism to direct traffic on to alternative, less congested paths. Now we see the one example of a message transfer in the OSI model. For illustrate the various layers of a OSI model, let us consider a simple example of message transmission. Let us assume that a process at sender node wants to send a message M to a process at a receiver node. Sender node's process builds the message M and passes it to application layer on its node. Application layer software add a header H7 to message and passes the resulting message to presentation layer. via an interface between layer 7 and 6, that is application layer and presentation layer. Now presentation layer software perform text compression, code conversion, security encryption and so on the received message, and after adding a header H6 to it, it passes the resulting message on the session layer, which is on the fifth layer. Depending on the type of dialog, session layer software establishes a dialog between sender and receiver process. It also regulates a direction. It also regulates direction of message flow. It adds a header H5 to the message and pass on the resulting message to transport layer 4. Transport layer software now splits the message into a smaller units like M1 and M2 called packets and add a header H4 to each packet. This header contains sequence number of these message packet. It then passes on this packet to network layer 3. Network layer software makes routing decision for the received packet and set up a logical path between sender and receiver nodes for transmission of this packet. It then adds a header H3 to each packet and passes them on to data link layer, which is on 2. Data link layer software adds a header H2 and a trailer T2 to each of these packets. The trailer contains checksum of data in corresponding packet. The resulting message units are called frames. Data link layer passes on the frames to physical layer, which is on first layer. Physical layer software transmit raw bits from sender node to receiver node by using the physical connectivity link between them. On receiver node, message data traverses up from physical layer to application layer. As it traverses it higher level layers, each layer performs its own function and strips of header or trailer added by its peer layer at sender node. For example, data link layer at receiver node performs error detection by recalculating checksum for each frame and comparing it with checksum in the trailer of the frame. It strips of header H2 and trailer T2 from the frames before passing them on to network layer. Finally, application layer of receiver node passes on the message in its original form to communicating process on a receiver node. Notice that software of a particular layer on sender node conceptually communicates only with its peer layer on receiver node, although physically it communicates only with adjacent layer on sender node. This abstraction is crucial to network design. So with this, I would like to end this lecture, and I think you have enjoyed this lecture, that is learning computer with seeing the natural sights of Indian village, and you have enjoyed it, I think. So I like to end this lecture here.